Okay, so this video is to cover how we can actually prove that some quadrilaterals are special, in that maybe it's a parallelogram or a rectangle or a rhombus or a square. Now, I chose the square because the square actually encompasses all of those. So we're going to go through and prove a square, and then we're going to talk about maybe you don't need these things if this is what you're trying to prove instead. So I figure we'll go through this one. So ultimately, what you normally start with is, here are some points, they're put on the graph, and either you have to plot them yourself or they're already there. In this case, they're already there. So I definitely want to go through and label these though. So if A is 0, 6, so let's put our little labels here. And we know B is 4, 9. So we're up here. We'll just kind of work our way around and label our points. It makes it a little bit easier if you're trying to keep your stuff organized. All right, so there are 4 different quadrilaterals that we typically focus on when we're trying to prove. And these were in our notes, but a quick little refresher. So the 4 are going to be a parallelogram, I'm going to leave a little bit of space right there with the parallelogram, so we can talk about that a little bit later. There's also the rectangle, rhombus, and square. So those are the 4 main ones that we're going to focus on here. Now, with a square, bare minimum requirements, bare minimum. And now a square has a whole bunch of other stuff that goes along with it, but you have to be able to prove that all 4 of the corners are 90 degrees. So we have 4 90-degree angles. And you have to be able to prove that all 4 of the sides are congruent. So you have 4 congruent sides. All right, well, each one of those things, so the angles are going to be totally different when we're calculating them as opposed to the sides. And again, this is one way to prove this. This is the way that we talked about it in class. So just like any other proof, you definitely want to start with what's given to you. So let's go ahead and list out everything that was given to us and put that in our top bubble. Now, starting with the given statement. We know that we're going to have to tackle the 90-degree angles and we're going to have to tackle the sides. So I propose we tackle the 90-degree angles first. Well, if we're talking about coordinate geometry, angles are going to be found by dealing with the slopes. Now, 90-degree angles only occur when 2 lines are perpendicular to each other. Perpendicular lines are lines where their slopes are opposite reciprocals of each other. So the signs are different and the fraction's been flipped over. So what we need to do first, really, is we need to take a look at the slopes. And I'm just going to go in alphabetic order. So I'm going to go from A up to B, put a little slope triangle on the outside here, and then across. I'm going to go ahead and create my right triangle. So starting at A and moving my way up, I'm going up 3, and then I have to go right 4. So what I'm going to say here is that my slope, and we know shorthand for slope is M, of line segment AB has a rise of 3 and a run of 4. All right. So what I'm going to do is I'm going to work my way around and find all of the slopes. So do the exact same thing to go from B to C. But remember, it's rise over run. So let's say I start at C. So I'll start getting my B to C. You can call it C to B if you want to. If I start at C, I'm going to rise 4, but I'm actually going left 3. So I'm going to do negative there. All right, let's keep working my way around. So B to C is done. Let's do C to D. I'm going to draw my triangle again. If I start at C, it looks like I'm going down 3, so negative 3 on top, and I'm going left 4. Well, we can go ahead and clean that up. We know a negative divided by negative is positive. And then the last one, you want to finish the loop. So we're going to go from D to A, or A to D. Doesn't matter where you start, just as long as you go from one point to the other. It looks like if I go from A down to D, it looks like I have a rise of negative 4, and I have a run of positive 3. Okay, so now all I did here was actually just calculate slope. So I didn't do anything fancy here. I've got those, my bubble. This is definition of slope. Let's go ahead and finish color coding this. So definition of slope. And that came from the fact, well, we couldn't do anything without actually having the shape. So I'm going to draw my arrow connecting the original given box to the definition of slope. All right, I propose we stick with slope. I want to take a look at these slopes though. If you take a look, I have that AB is 3/4, but so is CD. Okay, so those guys are parallel, but I don't actually have to say that. So I'm going to compare the AB and the BC slope. So if I take a look at the AB slope, I've got a positive 3 over a positive 4. Okay, I want to try to get this 90-degree angle happening, or this perpendicular business. If you take the 3/4 slope from AB and you flip it over and then flip the sign on it, it does in fact become 4 over 3, but now it's a negative. So see that that opposite reciprocal business is actually occurring from A to B, from line segment AB to BC. But if you take a look, we have that going all the way through here. So negative, or 4 over negative 3, flip it over, change the sign, you get 3/4. Take the 3/4, flip it over, change sign, you get negative 4/3. Let's see if we can finish the loop. Negative 4/3, all the way back to 3/4. Absolutely, we get the exact same thing. So what I'm going to do from here is I'm going to say, okay, well now I know because of my slopes, I'm going to kind of branch off to the side over here. Then I know that each of the line segments, well, I'm going to have that AB is perpendicular to BC, but BC was perpendicular to CD. CD is perpendicular to DA, and then let's finish this loop. DA is perpendicular to AB. Now, the reason why I know this is because the whole opposite reciprocal business, which is exactly what I'm going to say. A little line segment on top of AB. So I know that perpendicular lines have opposite reciprocal slopes. Okay, so that's good. So we've got this whole perpendicular business. Well, what does perpendicular mean? Perpendicular means that the angles are 90 degrees. Okay, so we'll arrow more off to the side here. Because I have all of these perpendicular business happening in the point of intersections with the line segments, I can now say that the measure of angle A, oh, that's 90 degrees. Measure of angle B, that's 90 degrees. Measure of angle C, also 90 degrees. And measure of angle D is also 90 degrees. So from here, well, how did I know that? Well, that's what perpendicular actually means. So this is going to be the definition of perpendicular. All right, back to the list. So back up to the very beginning. To get a square, we had to have, and I'm going to go ahead and underline this kind of up at the top, back to my list at the very top, 4 90-degree angles. Done. Got that taken care of. Next thing we need to talk about are the 4 congruent sides. For 4 congruent sides, that means that they're the same length. To find the length of a line segment, well, if it's just left and right, we can count the boxes. That's kind of nice. If it's straight up and down, we can just count the boxes. Unfortunately, none of these black line segments we started out with, so like A to B is kind of tilted or it's diagonal. But we can use this whole 3/4 business with the blue triangle. So I'm going to take this, I'm going to color code this guy purple. I want to try to find that length. That's what I'm looking for. So, well, it's got AB line segments on the end of it. So I think I'm just going to take this out to the side for a second so you can kind of see what I'm looking at. So here's my triangle up at the top. I've got a 3 of 4. It is a 90-degree angle. The question is, do I have sufficient information now to actually find out that slanted length? And the answer is yes, I definitely do. I do because this is a right triangle and I know 2 of the sides. Pythagorean Theorem. That's what we're going to do. Now, this line segment was called AB, and I'm just going to go ahead and stick with those letters. So I know back to the black box that we started with. Using Pythagorean theorem, if I take leg squared plus leg squared, I have to get hypotenuse squared. All right, let's do some math here. I know that 3 squared plus 4 squared, I can do in my calculator. It's going to give me 25. That's going to be AB squared. But remember, we're going to have to square root both sides. So when we do that, the square and the square root cancel, and you and I know the square root of 25 is just 5. Now, normally it's positive and negative 5, but this is a length, so it doesn't make any sense to call it negative 5. So I'm going to go back up to my picture, and I'm going to go ahead and just put a 5 there on that purple length. Now, I want you to take a look at this. All of these little blue triangle, slope triangles that we drew, every single one of them has a dimension of 3 and 4. And we're always finding the slanted length, which means we're always finding the hypotenuse. Okay, well, if it's 3 and 4, it's definitely going to continue being 5. But we do have to kind of show sufficient work that we are convinced and or convincing about this. So I'm going to go ahead and set it up again. So 3 squared plus 4 squared. This time I'm talking specifically about BC squared. Notice that the setup here for the AB squared and the setup here for BC squared are the exact same thing. So I'm showing my reader that I know these two are the same. I should be able to kind of go straight to the punch here. So I'm not going to do the intermediate step here. I'm just going to go, okay, well, hey, I already did that work, and I'm going to get 5 is equal to BC. Do the exact same thing with the other sides. Notice that it is 3 and 4 on all of those triangles. So let's just write it out. Like, hey, reader, I know exactly what this is. I already did the work. I know that that means that CD is 5. And then the last one, 3 squared plus 4 squared. Let's finish our loop. This is going to be DA squared. Okay, we already did the work. We know that 5 is equal to DA. All right, so now we've got this box immediately underneath. Again, we had to use those points to start, so I'm going to draw my arrow. Well, what did I do? I just did Pythagorean theorem. You could even say distance formula if you'd like. They're the exact same thing, especially on the coordinate plane. Okay, Pythagorean theorem. All right, so now I know that AB is 5, BC is 5, CD is 5, DA is 5. If they're all 5, then that means that they're all congruent. So remember, I'm trying to prove congruent sides. So from here, I can now say, all right, well, AB is going to be congruent to BC, which is now congruent to CD, which is also congruent, got to finish the loop, to DA. A reason why we know this, well, whenever you go from equal signs, and they're all the same number, you move it to congruence, this is definition of congruence. All right, back up to what we were supposed to do. To find a square, you have to have 4 congruent sides. Notice, in all of the blue boxes, we got the 90-degree angles. In order to get the angles, I used slope. All the purple boxes, I had to get congruent sides. That's a side length. So I had to do Pythagorean theorem. Well, I think I've got this. So the very final bubble that I have here now is like, okay, hey, I did all the work. I can now say that ABCD is a square. And there are a couple of things that you can say for the reason at the end. But knowing that in order to get a square, all you had to do was prove 4 congruent sides and 4 90-degree angles, can actually just say this is definition of a square. Again, we needed to use all of the blue boxes, so I'm going to find the end of the blue boxes. I'm going to draw an arrow to the final box. I needed to use all of the purple boxes, so I'm going to find the bottom of the purple boxes. Draw that. Okay, so here we have our proof for a square. But I do want to focus on this whole idea of, well, what if I was just, I'm back up at my list up at the very top. What if I am just doing a parallelogram? Well, parallelogram, bare bones proof is that opposite sides are parallel. So parallel comes from slopes being the same. So I'm going to color code this in blue. So for parallelogram, I need opposite sides to be parallel. but that comes from calculating slopes. So what's really nice about a parallelogram is that I don't have to do the Pythagorean theorem. It's not necessary. I mean, you can, but it's overkill. If you have opposite sides are parallel and it's a four-sided shape, it's definitely a parallelogram. I mean, it might be more specialized. Maybe it's a square, but it's definitely a parallelogram. Okay, with a rectangle, bare necessity for a rectangle is 4 90-degree angles. Okay, so we have 4 90-degree angles. Well, 90-degree angles only occur if the lines are perpendicular to each other. That's slopes again. So this is 4 90-degree angles. So all you're doing again is slopes. So notice I would only do the blue stuff. Now you got to be careful here. If you want the lines to be perpendicular, so 90-degree angles, that's the whole opposite reciprocal business for perpendicular. But if you want parallel, like for the parallelogram, that means that you need the opposite sides to be parallel to each other, which means they have the exact same slopes. All right, and then the last one that we really focus on here is a rhombus. Okay, bare bones for a rhombus. Bare bones for a rhombus is that all four sides are congruent to each other. Yeah, all four sides are congruent. Okay, so that means that we're only looking at the purple stuff. So this is 4 congruent sides, which means we're doing Pythagorean theorem for this guy. Now, that's not to say that you don't get a ton more stuff with these shapes. Like we have a whole bunch of stuff with the diagonals and the opposite corners and the central angle that's created when the diagonals intersect. There's a whole bunch of stuff that goes along with it. Like the bare bones that you have to prove to be able to get these things are what's listed up at the top.